we were talking about we were talking about collisions, and we were talking about elastic and inelastic collisions, and I had told you the definition of E, and at the last, I think we talked about oblique collisions, right? Oblique collision का हमने किया था ना discussion. मेरी आवाज आ रही है? So we are going to continue with oblique collisions. There are a few things more that I want to clarify. Once that is done, then we'll discuss briefly the study of spring mass systems as seen from the center of mass, right? And that will finish. So when we discuss collisions, I have told you, I have repeated again and again, that you must be on the lookout for external impulsive forces. Okay? So external impulsive force अगर किसी system के ऊपर लगा है, तो थोड़ी प्रॉब्लम्स आ सकती हैं. क्या प्रॉब्लम्स आ सकती हैं? अगर एक्सटर्नल इंपल्सिव फोर्स का कोई भी कंपोनेंट लाइन ऑफ इम्पैक्ट के अलोंग चला जाएगा, तो आप अब v1 प्राइम v2 प्राइम वाला फॉर्मूला यूज नहीं कर सकते. यू कैन नॉट डू दैट. फर्दर, you cannot conserve linear momentum in a direction in which the external impulsive force is acting, right? So you have to be very careful. There is something called the internal impulsive force, जिसकी वजह से collision हो रहा है. उससे हमें कोई ज्यादा मतलब नहीं है, मतलब वो केवल लाइन ऑफ इम्पैक्ट डिसाइड करता है. और एक्सटर्नल इंपल्सिव फोर्स का मतलब हुआ कि जो इंपल्सिव फोर्स is acting on the system from the outside. That is what we have to really look out for. So I'll give you a question. Try it out. A particle of mass m moving horizontally collides with a wedge as shown. If velocity of particle becomes vertical after collision, find E. Okay, so we have inclined plane of angle theta, mass m, and we have this particle moving with mass small m, moving with a horizontal velocity. There is no friction between the wedge and the plane. Chalo, please try this. हाँ, हाँ भाई नहीं हो रहा है। चलो देखो, I will show this and I will then give another similar question for you to practice on. So first of all, just like any question, you must identify the line of impact between the particle and the wedge. This has to be the line of impact. What this essentially means is that there will be an impulsive normal reaction on the wedge like this. There will be an impulsive normal reaction on the point particle. Now, after this impulsive, if I talk only about the wedge now, if the wedge experiences an impulsive force as I have drawn, then the wedge must, as a consequence, move in this direction. But the wedge cannot move in this direction because of the fact that there is the floor. So what will happen is that this normal reaction due to the floor and dash, this will also now become impulsive. Okay? This is also impulsive. And as you can see, the green and the blue arrows are not perpendicular to each other. And if they are not perpendicular to each other, this means that there must be a component of the blue arrow along the green arrow. Right? Therefore, we see that the system, okay, experiences an external impulsive force. Right? So not only is this statement important, what else is important is that the wedge experiences an external impulsive force. So the system does and the wedge does. Okay? नॉर्मल रिएक्शन है ना, तब फ्लोर का नॉर्मल रिएक्शन है ना, फ्लोर का नॉर्मल रिएक्शन इम्पल्सिव एन ड्यू टू द फ्लोर. अगर ऐसा नहीं होता तो ये वेट इस डायरेक्शन में मूव करेगा. हाँ, फ्लोर. हाँ, फ्लोर अगर नॉर्मल रिएक्शन लगाएगा तो वर्टिकली ऊपर लगाएगा ना. ओके, सो सिंस the system experiences an external impulsive force, therefore the V1 prime and V2 prime formula, right, cannot be applied. अब ये हम अप्लाई नहीं कर सकते. ठीक है भाई, अप्लाई नहीं कर सकते हैं तो अब क्या करें? So what do I know now? Let's read the question. Mass M is moving horizontally. So let's say that this mass M has, let's say that this mass M has a velocity of V0. Velocity of the particle becomes vertical after collision. That means after collision, the velocity of the particle, let's say, has become V1, vertical. And of course, the wedge must acquire some velocity. Let's say it is V2. I don't know the values of V0, V1, or V2. Right? The values are not given to me, which is okay, which I don't mind. So now that I have, hopefully you have understood that this is the initial picture. This is the final picture. Right? This is the initial picture and this is the final picture. What we can do is that we can now apply things which we have learned apart from the formula of V1 prime and V2 prime. What have we learned apart from the formula of V1 prime? Well, one thing that I know is that since momentum will be conserved along x-axis. Why will it be conserved along x-axis? Well, because there are no external impulsive forces along the x-axis. Along the y-axis, there are external impulsive forces. The external impulsive force due to the normal reaction due to the floor is vertical, is along the y-axis. So if I conserve momentum, I get initial momentum mv naught along the x-axis, final momentum mv2 along the x-axis. एक ये रिलेशन मेरे पास है. अब और क्या हमने सीखा है भाई? और हमने ये सीखा है कि अगर हम, मैं ये स्लाइड चेंज कर रहा हूँ 2 मिनट के लिए, अगर हम E की बात करेंगे, राइट, इफ वी टॉक अबाउट E, then we know that the definition of E is the component of relative velocity along the line of impact after collision divided by the component of relative velocity along the line of impact before collision. You know this? You know this is the definition of E. This definition of E is really independent of everything. It is just a ratio of relative velocity. So what I can say is that, look, initial velocity of the object was VO, and the initial velocity of the wedge was 0. The final velocity of the particle is V1, and the final velocity of the wedge is V2. And I also know that the line of impact is like this, which is along the normal reaction, between the wedge and the particle. Further, I also know that the normal reaction always makes an angle theta, which is the same as the wedge angle, with the vertical. And I also know that it always makes an angle of 90 minus theta with the horizontal. So this red line, which is along the normal reaction between the particle and the wedge, must make an angle theta with the vertical and angle 90 minus theta with the horizontal. Now let's find the components of the part of the velocities along the line of impact. Remember that this is the line of impact, and this is the only difference between an oblique collision and a head-on collision. In an oblique collision, you have to draw the line of impact, you have to find the components of velocities. In a head-on collision, you don't really need to bother with that, except for the fact, of course, initially you use the fact that all velocities are along the line of impact to define the collision as a head-on collision in the first place. But once you have decided the head-on collision, then you can forget about line of impact and everything else. So this component will be equal to V cosine theta, and this component will be equal to V1 cosine theta. This component will be equal to V2 sine theta. Right now, इसकी velocity, wedge की velocity 0 है before collision. So E का जो definition आएगा, that will be the relative velocity before collision along the line of impact. That is simply V naught sin theta, because relative velocity, अगर एक object की velocity 0 है, दूसरे की V है, तो relative velocity भी V हो जाएगी. Now, for the relative velocity after collision, I notice that after collision along the line of impact, this guy is going in this direction, this guy is going in this direction. So they are essentially going in opposite direction. And when two objects are traveling in opposite directions, we had come to this conclusion a very long time back. If there are two objects going in opposite directions, right, then what will happen is that the relative velocity will be the sum of these two velocities. So this will be V1 cosine theta plus V2 sin theta. E now becomes V1 by V0 cot theta plus V2 by V0. Okay? But look, we have already worked this out. यहाँ से मुझे ये पता चलता है that V2 by V0 is equal to M. I can use this here. I can say that E is equal to V1 by V0 into cot theta plus M by M. Now, if only I could work out V1 by V0, that would be wonderful. I would not have to, that would be the end of the question. V1 by V0 अगर मैंने work out. एक चीज और चाहिए, एक piece of information और चाहिए. Anybody willing to take a guess? Anybody willing to take a guess? विश्वजीत, एक्स एक्सिस के अलॉन्ग सिस्टम पे क्या एक्सटर्नल फोर्स दिखाई दे रहा है आपको? तो अगर एक्सटर्नल फोर्स 0 होता है विश्वजीत, तो कौन सा लॉ अप्लाई कर सकते हैं? हाँ, तीसरी कौन सी चीज यूज करें गाइस? No, we cannot conserve energy, Abhijit, because the collision is inelastic, so definitely energy is not conserved. Anything else you remember from our last class discussion? One thing I can think of, can you also think of that thing? Anybody guess? Can anybody tell me what something else is conserved? What else does not change? बोल रहा है जो है mass to infinity large का क्या मतलब हुआ?
But perpendicular along the उसके axis.
हाँ, फिर से बोल.
The perpendicular along line of impact वो नहीं change होगा ना?
बहुत very good, excellent. So the discussion that we had in the last class, I had told you that velocity components perpendicular to the line of impact do not change. Right? Velocity components perpendicular to the line of impact do not change. Right? But this statement was conditional. It was not absolute. It was conditional, and the condition was that there should be no external impulsive force on that object. Now, internal impulsive forces are okay. So this guy, this particle is subjected to an internal impulsive force, the green arrow. So this guy is subjected to an internal impulsive force, the green arrow. तो इसका जो velocity के components perpendicular to this force cannot change. However, the wedge is going to experience not only this impulsive force, it is also going to experience this impulsive force, and therefore we cannot say the same for the wedge. Therefore, I had written this statement. So therefore, the velocity component perpendicular to line of impact for wedge will change, but not for the particle, not for the particle. And if the velocity components perpendicular to the line of impact do not change, this tells me that V0 cosine theta is equal to V1 sine theta, and this means that V1 by V0 is equal to cot theta. And now I am in a very good position. I can say that E is equal to M by M plus cot square theta. So what are the three things we used? The definition of E is the second thing we use. What is the first thing we use? The conservation of linear momentum about an axis which is perpendicular to the external impulsive force. And the third thing that we used was the perp की condition क्या थी आप बताओ ना यार सर you were not taking notes in the last class. I told you ना आप अपना notes check करो last class का. So please take a screenshot of this. Please take a screenshot. आया सब समझ में? अगर एक्सटर्नल इंपल्सिव फोर्स एक ऑब्जेक्ट पे नहीं लगी है तो उस ऑब्जेक्ट का velocity component perpendicular to line of impact will not change. Please take a screenshot. Please take a screenshot. Okay. So now let's go to the next question. Three identical spheres are kept on a smooth horizontal surface as shown. So this is 1, this is 2, this is 3. Sphere 1 begins to move and strikes the other two symmetrically and comes to rest. Find E. यहाँ पे begins to move. We have to be very careful. Begins to move with constant velocity. बताओ भाई, कोई एग्जाम फटीग हो गया है क्या? I can understand. Still, यार विषय जीरो नहीं होएगा। देख, चल, 1 भी नहीं होएगा। Root 3 आंसर, Root 3 हो नहीं सकता है ना, 1 से ज्यादा होगा। 1/3 नहीं, 1/3 भी आंसर है। चलो मेरे को थोड़ी हेल्प कर दो, इतना तो हो ही सकता है। ये जो ई का, जो हम ई की बात करते हैं, E that we talk about, first answer this question. How many collisions are occurring? How many collisions are occurring? How many collisions are occurring? तो 3 तो बॉल ही है, जो है 3 कहाँ से हो जाएगा? 2. There will be 2 collisions, right? There will be no collision between 2 and 3. The collision will occur only between 1 and 2 and 1 and 3. There will be no collision between 2 and 3, although they are touching each other. When two experiences the sudden force from one, then this force is in a direction. This force is in a direction like so, and therefore the ball 2 will move along this yellow line. Similarly, the force experienced by the ball 3 on collision will be along this line, and therefore ball 3 will move along this line. So there will be no collision between balls 2 and 3. It will only be between 1 and 2 and 1 and 3. Now the E that we have defined, second question is that if the E that we have defined, is it, very close but wrong. The E that we have defined, is it between one collision, or is it between collision of two bodies, or is it for one collision, or is it for two collisions? The E that we have defined, is it for one collision or is it for two collisions? The E that we have defined, is it for one or two collisions or more collisions? It is only for one collision. Okay, it is only for one collision. Collision between two objects. But here we have two collisions between three different objects. नहीं वेदांत गलत है. So there is a simultaneous collision of 1 and 2 and 1 and 3. So just like always, okay, let's first uh, decide the line of impact. I've already actually drawn the line of impact. So two experiences in normal reaction and impulsive normal reaction. Here, one experiences an impulsive normal reaction. Here, uh, three experiences an impulsive normal reaction. Here, and one experiences an impulsive normal reaction. Here. Now I have written N for all. Would that be correct? I have written N for all. Would that be correct?
Sir, identical है तो correct.
Yes, very good. Very good. Yes. So it is correct. Yes, identical. Yes. So line of impact हमने देख लिया और हमने external impulsive forces बना दिया, right? Now let's focus only on one collision. So let's focus on these two guys. Let's focus on these two guys. Okay, we are focusing on 1 and 2. So now you have to answer the next question, which you will notice is the same as the question that I asked in the previous question. Next question is that, is there an external force, impulsive external force on the system 1 and 2? Is there an external impulsive force on the system 1 and 2? Is there an external impulsive force on the system 1 and 2? Yes, there is. Yes, there is. Where is it? There is an external impulsive force on the system 1 and 2, and this guy is it. This is the external impulsive force, because मेरा system तो 1 and 2 है ना, तो 3 तो external object हो गया. तो 3 ने 1 पे impulsive force लगाया है कि नहीं लगाया है? Answer is yes, लगाया है. तो इसका मतलब कि हमारे ऊपर external impulsive force आ गया system के ऊपर. Therefore, we cannot talk about V1 prime and V2 prime. So since there is, so I'm solving this now, an external impulsive force on the system 1 plus 2. This is by the object 3. V1 prime, V2 prime formulae are not applicable. You cannot apply that. So again, what do we do? What do we do? What can we do? Well, I can apply the definition of E. Relative velocity before collision, नीचे लिखना है. Relative velocity after collision, ऊपर लिखना है. Let's see. Let's say that these guys, very good Vedant, very good. Let's say that these guys move with a velocity of v1. Let's say that these guys move with a velocity of v1 after collision. Now I know that after collision, the velocity of ball 1 becomes 0. I know this. So let's first talk about the component of velocity along the line of impact of the object 1. Well, it is not along the line of impact. And further, I know that this angle is 30 degrees, right? Because of the equilateral triangle form. So the relative velocity before collision is V0 cosine 30 degrees. And the relative velocity after collision is simply V1, because object 1 to ruk gaya, object 1 is at rest, strikes the other and comes to rest. And object 2 has velocity v1, which is along the line of impact, so I don't need to take any components there. Now this is it. I cannot do anything else here. Now I take the system as the whole of the three objects. I take the system as the whole of the three objects. And I find that there is no external force on the system. Therefore, momentum along x-axis must be conserved. Why am I choosing only the x-axis? Well, I can choose any axis I want. But if I choose the x-axis, I am going to get a relation between V1 and V0, which is what I want. हाँ, 1 और 3 को भी लिख सकते हैं, बिल्कुल सही अथर बोल रहा है. Can we choose 1 and 3 as the system? Yes, we can. We'll get the exact same answer because of symmetry. So momentum along x-axis will be conserved. So I get mv0. This is the momentum of the system along x-axis before collision, and after collision it is equal to 2mv1 cos 30 degrees, right? Because this angle is 30 degrees and this angle is 30 degrees. So this will be v1 cos 30 degrees. This will be v1 cos 30 degrees. Please don't get confused or confounded by the fact that we have taken the system as 1 and 2 in the first case, and we have taken the system as 1, 2, 3 in the second case. Okay? This is absolutely all right. This is absolutely perfect. In fact, you should be, sort of building this mentality of being open to taking any systems for the different steps of a question. So I wanted a relation. So to find E, all I needed was the relationship between V1 and VO, which I have now. So V1 upon VO is equal to 1 by 2 cosine 30 degrees. So this will be equal to 1 by 2 into cos square 30 degrees. Should be 3 by 4. So the answer must be. Okay, so this is this is how to handle questions where you are unable to apply the formula for V1 prime and V2 prime, and you should check. 99.9% ऐसे question नहीं आएंगे, but you should check, right? And I think you guys will also be very lucky because ये जो अभी मेंस का एग्जाम हो रहा है इसमें बिल्कुल formula based questions are absolutely formula based, no complications whatsoever, right? I mean, if you solve the paper of mains in the syllabus that we have already covered, you will find that you are able to do more than 90% of the questions, right? So I think you guys, by the time you give this exam, the effects of the pandemic will still be there, and therefore I think that you will also get an easy paper like this, right? So we must double our efforts now studying. I'm going to change the slide. Please take a screenshot. हाँ, V1 equal to V2 सिमेट्रिक है. मैंने V2 लिख दिया है क्या? नहीं, V2 नहीं लिखना है मेरे को कहीं. कहाँ लिखा है मैंने V2? नहीं, कहीं नहीं लिखा है. देखो ना, V1 ही लिखा हुआ है. V1 सिमेट्रिक है ना, चेंज नहीं है. Okay, so now we want to talk about मुझे 2E आया एंड दोनों को इक्वेट करके बोल दिया V1. चले. So we want to talk about spring mass system. This is the last thing. Now there are a series of questions in FCV you have attempted where they say that look, this is M1, this is M2, this is K, and we give it a velocity V naught. So find the maximum elongation, or they may say compression of the spring. Okay. So how to do this? Well, you could take the approach of class 9, 10, 10, then you could, say that change in kinetic energy will be able to change in potential energy, and from there you can find the maximum elongation of the spring. But you will run into complications, and the reason why you will run into complications is that there are two objects and both are movable. Now, up till this point, when we were applying work energy theorem, it was guaranteed that, in fact, we had a discussion about this, that if the spring is at maximum elongation, then the system must be at rest. And the reason why this happened was because one end of the spring was always fixed. Either it was, either it was fixed to something which could not be moved, or it was just fixed. The key thing to remember is that maximum elongation or maximum compression of the spring occurs when the two ends of the spring have the same velocity. That means the relative velocity between the two ends of the spring is zero. In this case, it would mean that the relative velocity between M1 and M2 is zero. Then the spring would be in a state of maximum compression or maximum elongation. But unfortunately, at that point, the velocities themselves will not be zero. In other words, ये जो मैं बोल रहा हूँ कि M1, M2 का velocity जब relative velocity zero हो जाएगा, तब spring maximum elongation या compression में रहेगा. इसका ये मतलब नहीं है कि M1 और M2 का individual velocity zero हो जाएगा. इसका ये मतलब है कि M1 और M2 का velocity same हो जाएगा. Right? And therefore, this becomes a very weird and complicated problem. The motion of the objects itself is very complicated. M2 का motion कुछ ऐसा हो रहा होगा, M1 का motion कुछ ऐसा हो रहा होगा. So we don't want to go with that. We don't want to use that. What we want to do now is we want to use something more superior. And the more superior thing to use here is to shift into the center of mass frame of reference. Now, if ever you want to study higher physics, मतलब ऐसा ना हो कि जेई के लिए फिजिक्स पढ़ के आपका इंटरेस्ट इतना खत्म हो जाए, start hating the subject. So, if you ever go on to study higher physics, you will find that most of the time physicists, they like to work in the center of mass frame of reference. Makes things easy. For us, however, at our level, at our syllabus, we like to view things from the ground. We like to view things from the frame of reference of the ground, which in physics is called the frame of reference, laboratory frame of reference, lab frame of reference. Right? So we are not going to use these terms. We are not going to use lab frame of reference. We are just going to say that frame of reference of the earth. And we are not going to work in the center of mass frame of reference. However, it does make things easy. Therefore, this one time we will make an exception. In fact, you will find that this exception is always good if you are dealing with two or more movable objects, right? If you are dealing with two or more movable objects, somebody is asking you something, then it may be more beneficial to work in the center of mass frame of reference. Okay? I would advise it only to people who have a grip on relative velocities to go to do this. However, for two objects connected by a spring, uh, I will tell you the alternative, but this is much, much better. So first, let's try. First, let me show you the center of mass frame of reference wala method, and then I'll show you the normal wala method. So first, you work out VCUM, which in this case is equal to M2 V0 upon M1 plus M2, right? Because M2 was given a velocity V0, and at this point, M2 has not moved. It has just got a velocity of V0, and M1 is at rest. अब अगले सेकेंड में या अगले tick of time में M2 will move forward, the spring will get stretched, and then M1 will experience a force, and then M1 will be accelerated, and then M1 will get a velocity, and then M1 will move. But right now, velocity of center of mass is this. Or find acceleration of center of mass, okay, in case forces are given. इसको मैं ब्रैकेट में कर दे रहा हूँ, स्टार मार्क लगा दे रहा हूँ. ये यहाँ पे एप्लीकेबल नहीं है, ये उस क्वेश्चन में एप्लीकेबल है जहाँ पे हम फोर्सेस से डील करते हैं. Then find the velocity of particle 1 with respect to CN. Find velocity of particle 2 with respect to CN. So V1 minus VCN will be equal to 0 minus M2 V0 by M1 plus M2. Will be equal to minus M2 V0 upon M1 plus M2. V2 with respect to CN will be V2 minus VCN will be equal to V0 minus M2 V0 divided by M1 plus M2. And this will be equal to M1 V0 upon M1 plus M2. And in the force wala counterpart, you will have to find A1 with respect to CN, A2 with respect to CN. Right? Now, in the center of mass of frame of reference, so in the CN frame of reference, maximum elongation occurs when velocity of both objects is zero. This is the ये फायदा है फ्रेम ऑफ रेफरेंस ऑफ सेंटर ऑफ मास चूज करने. Irrespective of whatever initial velocity is given, remember irrespective, हाँ इक्वल नहीं, जीरो. क्यों ऐसा है? क्योंकि सेंटर ऑफ मास फ्रेम ऑफ रेफरेंस में मैं सेंटर ऑफ मास में बैठा हुआ हूं, तो मुझे सेंटर ऑफ मास की वेलोसिटी क्या दिखाई देगी? अगर मैं सेंटर ऑफ मास पे बैठा हुआ हूं तो मुझे सेंटर ऑफ मास की वेलोसिटी क्या दिखाई देगी? अगर आप बस के अंदर बैठे हो तो आपको बस की वेलोसिटी क्या दिखाई देती है? इट इज ऑलवेज जीरो. तो अगर मेरे लिए, मैं जो ऑब्जर्वर हूं, जो सेंटर ऑफ मास पे बैठा हुआ हूं, अगर मेरे लिए सेंटर ऑफ मास की वेलोसिटी 0 है, राइट, then what will be the velocity of the two objects? What will be the velocity of the two objects when maximum elongation has occurred? Right? Maximum elongation कब occur होता है भैया? Maximum elongation तो तब occur होता है जब velocities दोनों की equal हो जाती है, right? और अगर दोनों की velocities equal हैं, supposing v naught and v naught, so what will be the center of mass velocity? अगर मेरे को दोनों की वेलोसिटी v naught और v naught दिखाई देती है तो सेंटर ऑफ मास की वेलोसिटी क्या होगी? It will be equal to mv naught plus mv naught upon m plus n. That will be v naught. But that is not possible. We have just discussed that if I am an observer at the center of mass, then for me the velocity of the center of mass must at all times be 0. And you can see from v1 cum and v2 cum, you can see from v1 cum and v2 cum, you get a minus sign here and you get a plus sign here. That means that आप ग्राउंड पे बैठे हो तो आप बोलोगे अरे m2 राइट में जा रहा है, m1 तो रेस्ट पे है। लेकिन अगर मैं सेंटर ऑफ मास पे बैठा हूं तो मैं बोलूंगा अबे ऐसा नहीं है, m2 राइट में जा रहा है, m1 लेफ्ट में जा रहा है। Right? Because I am sitting at the center of mass, for me the velocity of center of mass must always be 0, and therefore the velocities of these two objects should always be such that m1 v1 plus m2 v2 should be equal to 0. So for what velocities will the velocity of the two objects be equal? For what value of velocity will the velocity of two objects be equal according to me sitting at the center of mass? The only answer is 0. या समझ में? अगर मैं 0 से कोई और डिफरेंस, मैंने बोला नहीं मेरे को तो कॉमन वेलोसिटी 1 मीटर पर सेकंड दिखाई दे रही है, तो ये पॉसिबल ही नहीं है, क्योंकि अगर मेरे को पार्टिकल 1 की वेलोसिटी 1 दिखाई दे रही है, पार्टिकल 2 की वेलोसिटी 1 दिखाई दे रही है, तो सेंटर ऑफ मास की वेलोसिटी भी मुझे 1 दिखाई देनी चाहिए, लेकिन मैं तो सेंटर ऑफ मास पे बैठा हूँ। दिस वुड बी लाइक यू सेइंग अच्छा मैं तो बस में बैठ गया नेरुल में और बस तो चली गई है और बस तो खारगर पहुंच गई है, मैं तो नेरुल में ही बैठा हुआ हूँ। दिस डज नॉट हैपन. If you are sitting inside the bus and the bus goes from Nerul to Kharghar, then you will also go from Nerul to Kharghar, because according to you the velocity of the bus is always 0 and the bus moves from position A to position B, and if according to you the velocity of bus is 0, then you must be moving with the bus. In the same way, if I am at the center of mass, then for me the velocity of center of mass will always be 0. And if maximum elongation occurs when the velocity of both the particles is equal, then this equal velocity can have only one value for me, and that is 0. Right? So therefore, maximum elongation occurs when velocity of both objects is 0. This is only according to the observer located at the center of mass. This is not according to the observer located anywhere else. Yeah, I'm going to change the slide. Please take a screenshot. Please take a screenshot. Okay. So, according to observer at center of mass. According to observer at center of mass. Initial kinetic energy half m1 m2 v naught by m1 plus m2 whole square plus half, मैंने उल्टा लिख दिया क्या? नहीं, half m2 m1 v naught by m1 plus m2 whole square. Final kinetic energy is 0. Initial potential energy is 0. Final potential energy half k x square, where x is the maximum elongation or compression. So just equate and you will get half kx square is equal to half, क्या कॉमन ले सकते हैं, m1 m2 v0 स्क्वायर कॉमन ले सकते हैं, और अगर ये कॉमन लेंगे तो हमारे पास बचेगा m1 प्लस m2 अपॉन m1 प्लस m2 होल स्क्वायर, से कैंसिल हो जाएगा. So x is equal to half half cancel हो गया, under root of m1 m2 upon m1 plus m2 k this will be the maximum elongation of the function. Now you may say कि नहीं नहीं मेरे को तो नहीं काम करना है ये सब, इतना दिमाग नहीं लगाना है, I don't want to do this. Well, can I do this without using this? Yes, you can. Okay, take a screenshot. I'll change the screen and I'll show you how to do this without. So when maximum elongation occurs, right, velocity of one is equal to velocity of two. We know this is equal to v, let's say. Okay, now we will get initial kinetic energy is half m2 v0 square, right? Initial potential energy is equal to 0. Final potential energy is equal to half m square. But final kinetic energy is now not 0, it is equal to half mv square, half m1 v square plus half m2 v square. Equate and you get half m2 v naught square is equal to half m1 plus m2 into v square plus half kx square. We'll get rid of this half. Now you can go back and you can say that look, the after acquiring this velocity, the external force on the system is 0 along the x-axis. Therefore, the momentum must be conserved. And if the momentum is to be conserved, right? So conserving momentum, you get mv naught is equal to m2 v naught is equal to m1 plus m2 into v. So therefore, v is equal to m2 v naught upon m1 plus. And then we can simply substitute this here. We can say that m2 v naught square minus m1 plus m2 into v square, which is m2 square v naught square upon m1 plus m2 whole square is equal to x square. Therefore, x is equal to v naught कॉमन ले लेंगे, m1 plus m2 से कैंसिल हो जाएगा, right? So I'll get m2 square upon m1 plus m2. We'll get m2 minus m2 square upon m1 plus m2 into v naught square. So x will be equal to 1 by k. You see m2 square cancel हो जा रहा है, m1 m2 upon m1 plus m2 under root so this is without going into the center of mass. This is without going into the center of mass. You can choose. However, in the next question, you will not be able to choose because you can do it, but it will be very lengthy, very lengthy. अभी तो थोड़ा सा ज़्यादा लंबा था, लेकिन जो नेक्स्ट क्वेश्चन है वो बहुत ज्यादा लंबा हो जाएगा अगर आप सेंटर ऑफ मास पे नहीं काउंट।
वो मुझे पिछले में डाउट है,
क्या है?
पिछले मेथड में डाउट है।
फिर से बोलना, नहीं सुनाई दिया, जोर से बोल।
सर पिछले मेथड में एक डाउट है।
हाँ, कि एक्स इंटरनल फोर्स है जो है। हाँ, क्या डाउट?
सर वो के फाइनल जो है ना सर, वो जीरो कैसे हो रहा है वो नहीं समझ रहा।
बताया तो, मैक्सिमम elongation occurs when both objects velocity is zero। फाइनल काइनेटिक एनर्जी कितना होगा?
हाँ सर समझ गया।
ओके, चलो नेक्स्ट। अरे विश्वजीत, इंटरनल फोर्स है के एक्स, एक्सटर्नल नहीं है। यस, कैंसिल हो ना हो उससे क्या मतलब है? इंटरनल फोर्स और एक्सटर्नल फोर्स। फाइंड मैक्सिमम elongation। So, step number 1, find ACUM। So, ACUM is equal to M1 A1। Right? Remember, the spring is not elongated at time t is equal to 0. Therefore, the force on N1 is F1. And therefore, its acceleration is F1 upon N1. Okay. Minus sign because it is in the negative x direction. Plus M2 F2 by M2 upon M1 plus M2। Actually, ये सब मुझे करने की जरूरत ही नहीं थी, सीधा लिख सकते थे that the net force is F2 minus F1 upon M1 plus M2। This is acceleration of center. 2 A1 with respect to center of mass minus F1 by M1 minus, so step आ गया ना, that you don't get confused, A1 minus S1, A1 is minus F1 by M1 minus S1, which is F2 minus F1 by M1 plus F2. Please work this out and tell me. I'm not going to work this out. A2 with respect to C1 is equal to A2 minus A1 is equal to F2 by M2 minus F2 minus F1 by M1 plus M2. Please guys work this out and tell me the answer. And we will arrive at a very shocking result. We will arrive at a very weird result. Please find A1 CUM and A2 CUM. लॉन्ग फ्रेम में बहुत लंबा हो जाएगा। केवल कैलकुलेशन करना है, कोई ऐसा एलसीएम ही लेके सब एक्सपेंड करना है। So here you will get something like m1 f2 plus m2 f1 divided by m1 plus m2, and here you get something like m1 f2 plus m2 f1 upon m2 into m1 plus m2. Now this result is shocking, or this result is weird, because to calculate नहीं ज़रूर गलत नहीं, ठीक से करना है यार, LCM ही तो लेना है. This result is shocking or weird if you decide to find the force on one with respect to center of mass, force on two with respect to center of mass. So force on one with respect to center of mass must be m1 a1 with respect to center of mass, and this must be m2 a2 with respect to center of mass. So if you multiply this expression, above expression, by m1 and the below expression by m2, you are going to get m1 f2 plus m2 f1 divided by m1 plus m2. And here you are going to get m1 f2 plus m2 f1 divided by m1 plus m2. Please notice that f1 and f2 were arbitrary forces. Okay? f1 f2 लिया, इसका मतलब different forces. अगर f1 f2 different forces हैं और जब हम center of mass से दोनों particles के ऊपर force measure करते हैं center of mass पे बैठे हुए, तो हमें दिखाई देता है कि दोनों masses पे equal and opposite forces हैं. दोनों masses पे equal and opposite forces हैं. Right? बहुत ही weird. अगर दो ऑब्जेक्ट हैं स्प्रिंग से कनेक्टेड हैं और उनके ऊपर आर्बिट्ररली डिफरेंट इधर उधर फोर्स लगे, स्प्रिंग से कनेक्टेड नहीं भी हैं तब भी वर्क करेगा. और अगर मैं सेंटर ऑफ मास पे बैठा हूं तो इट इज नेसेसरी दैट मेरे को दोनों ऑब्जेक्ट्स में इक्वल एंड ऑपोजिट फोर्सेस दिखाई देंगी. नाउ आई एम गोइंग टू चेंज द स्लाइड. प्लीज टेक अ स्क्रीनशॉट. Please take a screenshot. So if there are equal and opposite forces on two blocks, let this be m1, let this be m2. यहाँ पे F force लगा, यहाँ पे F force लगा, यहाँ पे K है. हाँ, external force है ना. तो maximum elongation क्या होएगा? This is what we want to find. So to find this, first thing I'll do is I'll draw a meter diagram. So this is the surface, this is the object 1, this is the object 2. इस पे force F लगा है, इस पे force F लगा है. Now after some time I find that object 1 is here, object 2 is here. This is the spring which is connecting them. So if the displacement of the object 2 is x2, displacement of the object 1 is x1, then summation of work done is equal to fx f1 x1. Sorry, f1 x1 would be equal to f fx1 plus fx2, that will be equal to f into x1. But what is x1 plus x2? x1 plus x2 is nothing but x. X is the maximum elongation. Now, maximum elongation मुझे कैसे पता चलेगा? ग्राउंड पे बैठे हुए हैं या किसी रिस्पेक्टिव, मैंने अगर इक्वल एंड ऑपोजिट फोर्स सिस्टम पे लगाई है तो ऑब्वियसली सेंटर ऑफ मास का एक्सीलरेशन 0 है, तो ये पूरा सिस्टम तो कहीं मूव नहीं कर रहा है। और हमें मालूम है कि मैक्सिमम इलॉन्गेशन तभी आएगा जब दोनों की रिलेटिव वेलोसिटी 0 हो जाएगी। In this case, that relative velocity 0 must mean that the individual velocities of the two particles must be 0. So this means that this is the summation of work done by forces. Summation of work done by spring will be equal to half k 0 minus x square. Initial kinetic energy of the system was 0. Final kinetic energy of the system will also be 0 since we are at maximum elongation. अगर velocities दोनों की 0 नहीं होंगी तो इसका मतलब कि ये ब्लॉक्स और आगे बढ़ेंगे, इसका मतलब कि elongation और ज्यादा होएगा। Maximum elongation by definition मतलब हुआ कि और elongation नहीं होगा। So I just equate and I get fx is equal to half kx square. So x maximum is simply equal to 2f by 2. Okay, if the forces are equal and opposite. If the forces are equal and opposite. So in the center of mass frame of reference, forces are always equal and opposite. This implies that x max is equal to 2 by k into this force, which we have worked out as m1 f2 plus m2 f1 upon m1 plus m2. Okay. Okay. So this completes this chapter. I would like you to complete now from your end HCV and the booklet. Please remember, like I have said, your paper, your mains exam will also be very, very easy. This is a very good golden opportunity. HCV करिए, booklet करिए, that's it. Next class say we will start with the next topic, which is a long topic. So it will stay with us. Rotation. उसको करेंगे, फिर हमारा मैकेनिक्स खत्म होगा। हाँ ओमकार बताओ। पहला ये साल इजी आया, अगला साल भी इजी आएगा। पहला, दूसरा ये साल इजी आया है बिकॉज ऑफ द पैंडेमिक, अगले साल भी इजी आएगा बिकॉज ऑफ द पैंडेमिक। तीसरा, चौथा, स्मिथ वो तो एसएचएम और ग्रेविटेशन भी है, राइट, बट फ्लूइड मैकेनिक्स और ग्रेविटेशन जो है वो दूसरे चैप्टर से सिमिलैरिटी रखते हैं, तो we can study them in conjunction with other topics. जैसे ग्रेविटेशन, इलेक्ट्रोस्टैटिक्स बिल्कुल सेम होता है, वैसा ही।
सर एक सेकंड पीछे लो।
कहाँ, कौन सा वाला बता तो मेरे को, ये वाला?
हाँ सर। सर आगे
और पीछे,
आगे,
आगे पीछे, आगे पीछे। हुआ? हाँ, चलो, great, good. चलो guys, HCV I will expect and the booklet I will expect पूरा, ठीक है? चलो।
सर आपने
हाँ।
जो रॉकेट वाला एक बार कराया था ना, वही वेरिएबल मास सिस्टम था क्या?
हाँ हाँ, वेरिएबल मास सिस्टम करा देंगे, दिनेश सर करा देंगे। आई विल मूव ऑन टू रोटेशन। चलो गाइस, बाय। ये लास्ट लेक्चर है ना, इसके बाद नहीं है ना लेक्चर?
नहीं है सर।
हाँ सर लास्ट
है इसके बाद?
सर लास्ट
नहीं सर, ये लास्ट।
अच्छा।